Activity 10.6, triangle congruence applications are more typical problems for triangle congruency. Number one is all based on the fact that the order of the letters matter. If you have triangle ABC congruent to triangle XYZ, that means A corresponds to X, B to Y, and C to Z. So if triangle CBA would then be congruent to triangle ZYX. You would reverse the order of the letters. Suppose you have a triangle ABC and you have JKL and you know angle B and angle K are congruent. So you know one pair of corresponding angles are congruent. If you want to show the two triangles are congruent by side, 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 what more would you need to know? Well, if it's three sides, then you're going to have to make a statement about the three corresponding sides. So you need AB congruent to JK. You would need BC congruent to KL. And then there's one more for you to complete to find a third side congruency. To show that the triangles, so let's put side, side, side here. To show the triangles are congruent by side angle side, what more would you need to know? So if you have side angle side, well, what more would you need to know? I already know that angle B is congruent to angle K. The angle has to be included between the two sides. So that means I also need to know that AB is congruent to JK and BC is congruent to KL. That would have B be in between the two sides, AB and BC, and K between the two sides, JK and KL. To show that the two triangles are congruent by angle, side, angle. Oh, there are two different solutions for this one. So let's do our angle, side, angle, angle, side, angle. So we know angle B, that's given, is congruent to angle K. So I have a choice to go to the left side or the right side. So if I do AB, has to be congruent to JK, then the angle has to come at the end of side AB. So then angle A has to be congruent to angle J. If I go to the right side, the other side of angle B, I go to BC as a side. That's going to be congruent to KL. Now you pick the side that's on the other end of line segment BC. So you fill out this missing one. Okay, next says, it's possible to draw two non-congruent triangles that satisfy the following conditions. It's not possible to explain why. And in the congruence activity in GeoGebra, you notice that there were two that were not congruence properties. So for example, angle, angle, angle is not a congruence property. So I can draw, for example, a triangle. Let's draw an equilateral triangle. So 1, 1, 1, where all the angles are 60 degrees. I can draw an equilateral triangle. That's 2, 2, 2. That has 60-degree angles as well. But these are not congruent. And it's asking us to draw examples of non-congruent triangles. If you know 4 pairs of parts are congruent, so that either means you have 4 pairs, can be 3 angles one side, or 2 angles 2 sides, or 1 angle 3 sides. Well, if I need to draw something that's not congruent, I just use side, side, side. I know that's a congruence property. If I have two angles and two sides, that's going to be side angle side or angle side angle. If I have three angles and one side, then I can use angle side angle. So this is not possible. If you have four pairs of congruent sides, the triangles will have to be congruent because any of the properties are going to apply. If you can't do it with four pairs, then you definitely can't do it with five pairs. So that is also not possible. You can try, give it some thought. So think about five pairs means three angles, two sides, or two angles and three sides. And you'll see that any of the congruence properties will fit, making those triangles congruent. Okay, number 4, then these look very typical, traditional congruence properties. So you want to figure out if you can conclude if these triangles are congruent or not. So if you have in A, you have this right triangle. In a right triangle, the hypotenuse is the longest side. So let me just put, I don't know, I'll put some numbers on here. For example, I'm making this up, but 5, and this one would be 4. So the double dashed line would be 4. This is my hypotenuse. But see how these two have a little slash through them? 5. That means that whatever this bottom side is here, and the hypotenuse has to be the longest side, which means it has to be greater than 4 and 5, but the hypotenuse here is 5, so these are not congruent. So the labeling matters in that one. If you have two isosceles triangles, so that means the base angles are the same, because these two sides are the same. That means this angle is 70. We can do a little math. 180 minus 70 is 110. 110 minus 70 is 40. Which is up here, so these are congruent. What property? Well, we can, not side, 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 but I think either angle, side, angle, or side, angle, side is good. Okay, so those are two examples. Why don't you go ahead and finish the rest of the examples? So you're trying to figure out if they're congruent or not congruent, and if they are congruent, you're trying to figure out the property that makes them